Our last topic and everything that we've done with rational expressions builds into solving rational equations. And so we're going to solve some equations, yeah. And in doing so, we are going to look at a couple different strategies. One strategy here, it is just, if you have fraction equals fraction or rational expression equals rational expression, then do cross products. So cross products would be, saying A times D. A times D is equal to B times C. And then you can solve it from there. Okay, that would be the strategy for that case. But that is very particular. You have to have fraction equals fraction. All other cases, right, and I have this in bold. I'm going to highlight it again, though. We want to multiply by the common denominator among all terms on both sides of the equation. That will clear the denominators after we simplify. Okay, so then we just don't have to work with fractions, right? Or rational. We're working with rational expressions, just not anything with a denominator. Okay. All right, let's dig in. We're going to solve three equations together. First one, this is the fraction equals fraction case. So I can do cross product. So I can do 3 times x plus 1 is equal to 4 times x minus 2. Okay, and then I can, so 3x plus 3. Okay, we're good at solving these things. Yeah, okay, subtract, so I'm going to subtract 3x from both sides and simultaneously add 8 to both sides so that I get, on the right-hand side, I get x, and I get 11 on the other side, and I note that 11 is not restricted, right, or is not an undefined value, so just here we note x can't be 2 and -1. Otherwise, if we did get one of those values, we would just have to remove it and potentially say no solution. Okay. All right, next one. Now this is all fractions, but it's not of the form fraction equals fraction, right? So I can't do that. So the other strategy, right, was find the common denominator among all of these. Okay, so I think if I were to multiply them, I think that's my best choice at a common denominator, 15y. Okay, so then I want to multiply. Let's say I want to multiply this by 15y. I want to multiply this by 15y, and multiply this by 15y. Okay, and I'm just going to erase it so I can see the signs. So I get 15y over y plus 30y over 3 plus is equal to 15y over 5. If I simplify that, right, I get 15 plus 10y is equal to 3y. Oh, that's easier to solve, right? Subtract 10y, 15 is equal to -7y, and then divide by -7. And I get y is equal to, or -15 over 7 is equal to y. Okay, so that's a bit easier, yeah? Okay, then as soon as multiplying them by that common denominator really helps. It gets rid of the fractions. Okay, what in the world are we doing here? We question our life a little bit, and then we proceed by saying, oh, yeah, these are rational expressions, and the best way to simplify them and to find a common denominator is to factor, one of Professor Bright's favorite F words. So if we factor this, right, this would be 5y minus 2, 3y plus 2, and, oh gosh, over here this would be 15y minus, or y squared minus 4. Oh, and that's actually 15y minus 2, y plus 2. Oh, okay, so I think I see that the common denominator between everything, right, it'll have a 5y minus 2, 3y plus 2, which is all the same as 15, and then y minus 2, y plus 2, which is on the other side, okay? But now what I'm going to do is multiply each component of this by that common denominator. So y minus 2, or y is 15, y plus 2, y minus 2, 15, y minus 2, y plus 2, and then times 15, y minus 2, y plus 2. Okay, now this is looking intense. It'll be fine. Okay, so I have y, and then times 15, y minus 2, y plus 2, over 5, y minus 2, minus 5, and then times 15 times y minus 2, y plus 2, over 3, y minus 2, or y plus 2, I'm sorry. There we go. And then this is equal to 2y squared minus 19y plus 54, and I want to multiply all that by 15, y minus 2, y plus 2, all over 15, y minus 2, y plus 2. Okay, now that we have carpal tunnel, okay, now we can cancel common factors as long as we note, okay, we should note, okay, y can't be plus or minus 2, okay, but now we can cancel common factors. 15 and 5 reduce. Y minus 2's cancel out of the first fraction. Next up, we have 3 going into 15 5 times, and then the y plus 2's cancel. And then look at the right-hand side. Oh man, that felt good. All those things cancel out. Okay, so what is left after all this? Y times y plus 2 gives me y squared plus 2y minus, and then I have 25 distributing into there, so I'd have 25y plus 50y, no, just plus 50, okay, plus 50 is equal to 2y squared minus 19y plus 54. That's a 54. Okay, all right. Oh man, okay, y squared minus 23y. Are we done yet? Okay, I really hope so. But we're not, because we have to solve a quadratic equation. Okay, so we have all this, and then I'm going to move everything over to the right-hand side. So if I do that, I get just a y squared. Adding 23y gives me plus 4y. And then subtracting 50 gives me just 4. Oh my goodness, doesn't that simplify quite nicely? 0 is equal to, this factors is y plus 2, quantity squared. Square root property, oh man, we're using all the tools in the toolkit. Okay, and then solve at long last that was y, but then hold up. Okay, we had a restriction, yeah? Y can't be plus or minus 2, so you do all that work just to say, just kidding, this is no solution, or undefined, okay? Wasn't that fun? Not really. You're probably like, why did we even do the damn problem? But you can solve it, but you need to make sure that you're checking the values you get against the restricted values. Okay, if you end up with something that's restricted, you have to remove it and just say no solution. Okay, so other than being incredibly frustrated with the last one, but we built a lot of character, good job. We now know how to solve rational equations, right? By either cross products, if we have fraction equals fraction, or multiplying both sides by the common denominator and carrying that through carefully. All right, congratulations on making it through all this.